Hi, good day. Welcome to today's tutorial class. Today I'm going to take you through the Kruskal-Wallis H test. The Kruskal-Wallis H test is a test that we use to compare three or more independent samples or groups. It is just opposite one-way ANOVA. And if you want to know more about the one-way ANOVA, I will encourage you to just go to my YouTube channel. I have a video on one-way ANOVA. Also, the Kruskal-Wallis A test is an extension of what we call the Mann-Whitney U test. The reason being that this is for three, while the Mann-Whitney U test is only for two groups. So when do we conduct the Kruskal-Wallis if we decide not to conduct a one-way ANOVA? There are two conditions which I will state here, but you can also check up about other non-parametric assumptions. So one, if your data set is not normally distributed, and I have a video on how you can check the normality or the normal distribution of your data set. So watch that video as well on my channel. And then also other non-parametric assumptions. So not normally, the data not normally distributed is one of the non-parametric assumptions, and all the other non-parametric assumptions. If your data set meet them, then it's good for you to conduct the Kruskal-Wallis A test if you are dealing with three or more independent samples. So in this context, or in this example, I'm hypothesizing that there's no differences between the opinions of the professionals. So there are a number of professionals here, four professionals, which I'll show them to you very soon, construction professionals. We have the architect, we have the QS, which is quantity surveyor, and then we have the site manager, and then we also have consultants. So I'm going to compare their difference here. I'm assuming that in the null hypothesis, I'm assuming or I'm hypothesizing that there's no differences between their opinions. And their opinions are on 24 questions I asked them. And you can see their responses here. And the number of respondents are 100. I'll go down very soon to show you. Then the alternative hypothesis is that if there is no differences between the opinions of the professional, then the alternative hypothesis is that there are differences in the opinion. So let's test this. So here I have 24 questions, and then the number of respondents are 100. I have 100 respondents, or I got 100 responses. Okay, and 24 questions. And I'm going to check whether there are differences between these four groups of professionals in the construction industry that responded to this or to these questions. To do this, very simple, I'll just go straight to my SPSS. If you have SPSS, just open your SPSS. And then you can set your data up. So here, I'm going to set it up, the names, these are the questions. So I have 24 questions. So I have 24 questions. Yeah. So I have all my 24 questions set. Okay, good. But in this context, I'm going to take away the decimals. I don't want any decimal to show. so that we will see the figures that we put there. So the decimals should be turned to 0. Okay. When it comes to where the figures, I want them to be at the center. I want the numbers I'll copy from my Excel sheet to be at the center. So all of them is going to be at the center. Or you can just leave it as it is. It's not really important, but I'm just trying to position. Where do you position? Okay. It's not really important, but you can do it. Okay. So all of them at the center. I'm just trying to make sure that my 24 data set, everything is at the center. So that when I copy them and put them there, to be easy to work with. Okay, then when it comes to the measure, because they are figures, either you can decide to choose scale or ordinal. Okay, but this contest I'll choose scale. Yeah, because it's ordinal. In other words, they are being ranked like a scale. Or if they are not like a scale, you just choose scale. This scale in this contest represents the ratio or the interval scale. So I'll just choose scale. Just choose scale for all of them so that it will be easier for me to just copy the figures and put them there. So from the variable view, you go to the data view. So you see that all the numbers have been put there. You can see them, right? So I'm going to copy by 100 responses. I'm going to copy all these 100 responses and just come and paste them on the data view in the SPSS. So just copy and just come and paste them from here. Yeah. So everything has been copied. Yeah. So you can see all the 24 copied. Okay. Up to the 100. You get it, 100. Good. Now, I mentioned that. So we go to the variable view again. I mentioned that the professionals are 4. So you set up the professionals. The professionals are 4. Okay. The professionals are 4. So you go to values. Okay, under on the professionals row, and then you click on this 3 dotted points, and it will open this for you. When it open, then now you add the professional. So 1 will represent what? Architect. 2 will be for the QS, which is quantity surveyors in this contest. 3 for the site managers. And then 4 in this contest will be for consultant. But It doesn't mean it's always going to be four. It could be two, it could be three, it could be some, I mean, it should be three or more. It can never be two. If it is two, then you have to use the man-Whitney U test. Okay. So it should be three or more. So it could be more than the four. It could be five, it could be six, depending on the number of respondents that responded to your survey, the groups. Okay, so here I have four different categories of professionals who responded to this survey. Okay, so I click OK. And then when I come to the data view, you see at the extreme and after the question 24, you see the professional. So here I have to put in the kind of professionals I'm dealing with. Okay, so you see the question mark. So here I mentioned that, or in this context, I'm saying that the first 25 are architects. So 1, 1, 1, 1, 1, 1. Anyway, let me change this to the center so that it will look nicer. Yeah, so the first 25 responses. In this context, I'm assuming. But when you are dealing with yours, you can interchange the figures because sometimes you get a professional who will be an architect who responded to the first one. Maybe the second person was a QS. So depending on how they responded. So here can be one, two, the other one will be one, four. This it depends. You can arrange that. But in this context, I just want to make things in order. So the first 25 I'm assuming that they are all architects. Then the next 25 up to 50, I'm also going to here assume that they are all QS. And then the next 25, I'm going to assume that they are all site managers up to 75. So in this context, I'm assuming that each group gave us 25. But once again, it doesn't mean it will be the same. Okay, when I say it will be the same, sometimes you get 20 people responding who are architects, and you get 50 people who are QS, and you get 10 people who are this. So yeah, but here I'm just assuming that 25, 25, 25 of these four groups of professionals responded to my survey. Yeah, it's just for an example's sake. It doesn't mean that yours will be the same. Okay, so good. So I have all these professionals. Yeah. One is for architects, two is for QS, three is for site managers, and four, the number four. Okay. That means when you go to the left-hand side, all the four, all those who responded to this are considered to be what? The consultant, the four, and the one is architect, and the two is QS, and then the three is the site managers. Okay, now good. So I've set my data up. So what next? The next thing is to analyze the Kruskal-Wallis. There are two ways by which you can analyze the Kruskal-Wallis. You can come here, analyze, and then you click on non-parametric test. The first approach is by using the independent samples approach. Okay. Then after that, once I'm done with that, I will use the legacy dialog. That's the second approach. Okay, or the second route, or the second way, or the second, but it should give you, the two of them should give you the same answer. Whether you use the first approach by clicking on independent samples or by using the legacy dialog and coming to select two K independent samples, any of them should give you the same answer. So I'm going to start with the independent samples. So when you click on this, it will give you this, it will open this for you. And then you click on fields. So with the fields, you select all the 24 questions in this contest. Okay, because we just want to know for each of them, each of the questions, we want to know whether the professionals, the four professionals, the architect, the QS, the site managers, and the consultant, whether they have different views on each of the question, if or they have the same as we set for the hypothesis. Then for the groups, you click on this. So this represent the professionals as I set them up. Then you click on run. But before that, you can also, yeah, I mean, you can just go straight. Let me go back again. Yeah, and then the settings. Okay, I didn't choose. Okay, so the first thing is you open this, you take fields, good, and then you go to settings. So settings, you have to customize by choosing what you want to run. In this context, we want to run a Kruskal-Wallis. So you need to select. Yeah, I think on default, it will run the Kruskal-Wallis for you or the Man Whitney or one of them for you, but you need to select the one that you want to work with. So in this context, we want to work with the Kruskal-Wallis. Multiple comparisons with all the pairwise comparisons. Yeah, so once you select that, you click run. So once you click run, it will give you go up, go up to give you the uh, the the resource. I will encourage you to focus on something and leave the rest. The others are just and the pairwise comparisons and all that are just something that help you to know where the differences are coming from. But the main resource that you have to focus on is this resource. Yeah. So you have to focus on this. Right? So let's look at each of the questions. So 24 questions. So with respect to the first question, it's saying that we have to retain the null hypothesis. That means concerning the first question, there's no significant differences between, yeah, based on our null hypothesis that we stated from the beginning, right? That means there's no significant difference between the opinions of the professional, so we have to retain. And the reason why we have to retain that is that the significance level is 0.017. Okay. Yeah. And then it's 0.017, which is more than the significance level of 0.05. If we got a significance level of 0.05 or something less, let's assume we got something like 0.0004, then we'll reject the null hypothesis. But in this context, the significance level is more than the significance level, which in this context could also be explained as the p-value. It's more than, it's greater. And anytime it is greater, you rather retain the null hypothesis. You don't reject. But the only time that you reject the null hypothesis is when your p-value or the significance level is less than. If this figure was to be less than 0.05, then we'll reject the null hypothesis. Okay, so question one, we'll retain the null hypothesis. The same thing applies to all question one up to all the questions. Okay, so I can see from here that question 12, we are rejecting the null hypothesis. We are rejecting the null hypothesis. That means, yes, there is a significant differences on the opinions of the professionals concerning the question number 12. Yeah, when you reject the null hypothesis, you have to accept the alternative hypothesis. The alternative hypothesis said that there are significant differences between the professionals. That's what we stated for the alternative hypothesis. Okay, good. Then you interpret. So you interpret that. So with respect to question 12, yes, there is a significant difference between that, but the rest, uh, almost all of them, we don't have any significant differences between them. Now let's go to where, if you want to go deeper, so the rest, they are all the same. You go to question number 12 and let's see where the difference is coming from. Well, let's go and see question number 12. So that's where, yes. So question number 12, what we are seeing compared to the other ones where we saw that their whiskers, okay, their whiskers were almost the same or they are related. It seems question number 12, um, some of the whiskers are not even appearing. And then it seems in question number 12, we even have some outliers. Mhm. Yeah, yes. So the whiskers are not showing of the other apart from the site manager's whisker, which is showing, the rest are not showing. Also, we can also look at the pairwise comparison. And the pairwise comparison, you can see that yes, this is where the differences are coming from. Between the site managers and consultants, the significance level is 0.04. Yeah, so there's a difference between the opinions of the site managers and the consultants. And there's also a difference between the opinions of site managers and architects, which they also got 0.04. But the rest, there are no significant differences between them. Okay. The site managers and the QS and consultants, the QS and architects, consultant and architects, their P values are more than 0.05. Therefore, we retain the null hypothesis. Also, I can also check. Yeah. So that's question number 12. Yeah. So it's also evident here. It's even evident. You see with the colors, you know. So the ones with 0.05, less than 0.05, these are the ones. There are no significant difference between them. But these ones with red, they have more than, okay? The QS, as we saw it from the table, is the same thing which has been shown in the pairwise comparisons. Okay, yeah. So that is all for the Kruskal-Wallis first route or the first approach. Then you can also use the second way by to go about it. The second approach is by using the dialog, the legacy dialog box or the legacy dialogs. Here you select the K samples and you should get the same answer that we have seen. So put all of them here and with respect to the group, you put them here. It will ask you how many people are you working with. So you have to define the people that, so the minimum is one. The one here refers to the architect, and then the maximum is four. In other words, we are dealing with four groups. The minimum is one, and the maximum is four. So if you are dealing with three groups, the minimum will be one, and the maximum will be three. If you are dealing with 10 groups, the minimum will be one, and the maximum will be 10. If you are dealing with seven groups, the minimum will be one, and the maximum will be seven. If you are dealing with seven groups, and so forth and so forth. So okay, and then you click on. Let me check options. Okay, so here we don't have, if you want to show the descriptives, that's okay. But if you don't want, that's also okay. Uh, let me show the descriptives. And then if you have missing values, if in case any of your responses are missing values, you have to also show them here. So, okay. And then let's see the results that will come up. Okay. So the results are here. Now what can we see? Okay, so this is the results for the Kruskal-Wallis. So as we can see, the asymptotic significance shows that they are all question one, question two, up to just like how we saw it. It's only question 12, just like how we saw it from the other approach. It's question number 12, which has a significance level which is less than 0.05, and therefore we rejected and we said that there is significant differences between them. But the rest, when I say the rest, all of them, they all have asymptotic significance value which are more than 0.05. And therefore we retain or we accept the null hypothesis. It's only question number 12 that will reject the null hypothesis. Okay, yeah. So, and then the descriptives are up here. The descriptives are up there. So it shows for each of them, each of the questions, the differences in terms of the number, and then how they responded to the questions. The mean ranking, each of them. Okay, that's not our focus. Our focus is the Kruskal-Wallis. That's the most important thing for us. So focus on this table. Okay, so this table is showing that all the variables, all of them have significance level which are more than 0.05, except this. So thank you very much, and I wish you all the best. See you in another video or see you in another class. Keep on watching. Okay, I will encourage you to watch the videos. Just take your time. They are easy to run, they are easy to follow. So just take your time, run them, and then learn them. Okay? Yeah, if you have any question, just put them in the chat box. In fact, if you want to even send me an email or you have a question that you want to ask, you can even reach out to me via email and I'll help you out. Okay, so all the best and have a good day. Bye.